Students, here we are going to start electric current. This is a chapter which is called current electricity. So what is current? Current is basically flow of charge per unit time. Current is basically flow of charge per unit time. And for this, we write in very simple words, that is I, that is the current, that is flown charge divided by the time. But only this much is not sufficient. We should know how the charge flows. The one way is this: our electron or proton flows in any one direction. This is a positive charged proton. It is moving. So if we see it at a point, so from there, from a cross section or from a particular area, the number of charge which are passing in this way in the space, so that is the flow of charge per unit time. On calculating it, we will be getting the current. In the same way, we are having a proton in the nucleus of the hydrogen. Around it, the electron performs the circular motion. And here the electron which is performing circular motion, so E charge, E is the electronic charge. Suppose N is the frequency. N is the frequency of revolution around the nucleus. So here the electronic charge in 1 second moves N times around the nucleus. So on this circular path, a current will be there. And you can see that current, how much it will be. Charge per unit time. In a second, how much charge is flowing? The electronic charge flowing is N times. That means E into N. In 1 second, how much charge is flowing? Electronic charge is flowing N times. N times the same electron revolved here. So our current becomes N times the E. This is also written as EF sometimes. F is the frequency. So this is the current. Now what's the other type of current beside this? Apart from this, we see the current in an electrolytic cell. Between two electrodes, current flows. How the current flows? The ions are there. Suppose we are having OH negative ions here. It is moving in one direction. It is moving towards positive charged plate, and suppose our H plus ion is moving towards negative plate. It is going to the plate of negative potential. So what is happening here? Here the ions are carrying the charge. So here also current calculation can be done. This we don't study in the current electricity. This we study in the electrochemistry. Apart from this, we have to understand what happens in a metal. See what happens in a metal. In the metal, suppose we are having a metal piece. This is our metallic piece. Here many electrons are there. There are large number of electrons in a metal. And the electrons which are there in the metal, they keeps on moving randomly. Metal consists of gas of electrons. The electrons in the metal move in the same way as in our room the gas particles moves. They move randomly. The motion is there in any direction in this way, and they collide with each other. Here the speed of the electron will be getting the RMS speed. So the RMS speed is 3 K Boltzmann's constant T temperature upon mass of the electron. But in the metal, due to this random motion, there is no net flow of charge. If you see the net flow of charge in a cross section, so it is not there, because the number of electrons which are moving in one direction, some electrons are moving opposite to them. So in this way, electrons does random motion here. In no one direction, net flow of charge is there. And Vrms have a big value here, that is 10 to the power 5 meter per second if we talk about the normal temperature, then nearly equal to this. So how the electrons move, what we call them in the metal, how do they move, this will be seeing. And what are the other definitions of the current? Let us see them. Electric current means flow of charge per unit time. So now let us see how we measure it. In which ways the charge flows, this you have seen. Now we are seeing this in much detail. Now we are seeing direct electric current. What is direct electric current and what are the currents apart from this? One is alternating current. Alternating current we'll be studying in the later chapters. What happens in the alternating current? The direction of the current, suppose the current is flowing in a wire, so the direction of the current continuously changes. And if you plot the magnitude of the current with respect to time, so it can be in this way or some other type of waveforms can also be there. This we call it as the waveforms. So this is alternating current. What is happening in the alternating current? Direction of the current is changing. Initially it was flowing here and now it is flowing here. Why the current flows? The current flows due to the potential difference across the conductor. So if the potential difference is changing again and again, potential difference is changing its direction and the magnitudes of the potential difference are changing, so the corresponding current will also change its magnitude and the direction. While direct electric current, that is the DC, in short it is called DC. How the DC currents are, if you plot the DC current with the time, with respect to time. So this is one example of DC current. So this DC current is having constant magnitude and the direction is same. By direction we mean, you can see this is positive x-axis. So direction is positive, this means we have taken it above x-axis, we have taken it above t-axis. This means the direction of the current is same. This is the I-axis, this is the negative I-axis. If you see down, then here the graph means the direction of current became reversed. So here the direction of the current is same, it is positive. And what is the amount of the current? The amount of current is this much, it is equal to this point, that is value of the current at the point. This is suppose I naught, some current. And even you can see the magnitude of the current, it is constant with respect to time. So this is a constant DC current. The magnitude of the DC current can change. It can decrease or increase, but the direction will be same. So in this case we see one direction, if you see in this way, so it can be somewhat like this. The graph of the current can be in this way with respect to time. So it will become variable DC. That means variable direct current. So the direction is same, but the magnitude is changing, but it is moving in the same direction. Like the crowd move in the same direction, sometimes slower, sometimes faster. Like you might have seen a crowd in the temple, it moves in one direction, sometimes slower, sometimes faster. From a one-way road, so sometimes it is slower, sometimes faster. So this is the same direction basically. So this is direct electric current. How we measure it, let us see it forward. A car battery is rated at 80 ampere hour. An ampere hour is a unit of ampere into hour. What is ampere? Ampere hour. What is ampere? Ampere is coulomb per second and hour is basically 3600 seconds. On cancelling out second, then you will be getting the unit, and if you see in the point of view of unit, then it is coulomb. It is the unit of charge. So ampere hour is basically coulomb, that is the unit of charge. Drift velocity. How the drift velocity is there, let us try to understand this. Electrons inside a metal, you will be seeing these are electrons, and electrons perform random motion. Zigzag random motion is there, whose speed we have seen, the speed of the random motion. Its speed we have seen 10 to the power 5 meter per second. But when we apply the potential difference, with the help of a battery, then what happens? Suppose here we have applied a positive potential and here from the help of the battery we have applied negative potential. So inside, if we talk about this battery, then the EMF of this battery is